Welcome to Live Life Better. This is Scott Eastwood. I want you to live the best version of your life. We're all human beings, all just trying to figure it out. Find something you love and chase it. Oh yeah, we are back with Live Life Better, and this is Scott Eastwood and Timothy. Today on the podcast, we have Rhonda Patrick, Dr. Rhonda Patrick. That's right, she is an MD, and she is awesome pants. The first time I heard her was on Joe Rogan, and I said, I want to talk to her about everything. She is a wealth of knowledge, and I really think you people will get a lot of benefit listening to this podcast because she really talks about how we can be healthier, which is the whole reason that we're doing this podcast. So check her out. Hope you enjoy it. There's a little bit of sound quality because we did it at my house. So there's a little bit of sound issues in the beginning, but bear with us. Check it out. Thank you so much for coming. I think the first time I heard you was on Joe Rogan, and I was like, oh my God. I couldn't believe how much and how you were just saying how dense some of your stuff is. And I was like, I need to go back and listen to this again because I was so enthralled with all the stuff you had to say. I'm like a kind of a fitness freak in the sense that I'm like, I always want to like find out what the best thing I can be doing for my body is. Like, my dad early on kind of pushed that on me. Is like, you only get one body, and like, how can you be the best version of yourself? So I was super like interested. And then I think you've been on maybe 7 more times to this podcast.
7 total. And every time I'm like, oh my God, there's another one.
So I was like, I have to have Rhonda Patrick on.
That's awesome. That's flattering. I really appreciate it.
Yeah.
I'm excited to be here.
Yeah, well, I'm excited you're a San Diegan too.
Yeah. Born and raised, flew, took about 9 years off when I went to grad school and did my postdoctoral training and whatnot, but found my way back here. So.
And you did, correct me wrong, you did some of your college education in San Diego, right?
Yeah. I did my undergraduate research and my undergraduate education here at UCSD.
Got it.
And I worked at the Salk Institute for Biological Sciences for about 2.5 years, right after I graduated from college. Did research on aging there, and that was like my first interest in in biology.
Sure.
I was a chemistry undergrad student, so I did a lot of chemistry, organic chemistry, synthesizing compounds and things like that, and I got really bored with that. So when I joined this aging lab, it was like, whoa, this is the coolest thing ever. Doing things where we would take little nematode worms that have a lot of genes that are homologous to humans. I mean, they're a little different, but essentially do the same thing, like an insulin receptor, and and then make something like insulin and all that. But one of the first experiments I had done was changing just one gene that decreases their insulin-like growth factor, IGF-1, which humans also make. And
how do you change that? How do you manipulate that for people who don't know anything about science?
For the worms, it's super, super easy because they eat bacteria. They eat like E. coli. And so you can spike something in their bacteria that basically will turn off select genes. So it like binds specifically to a sequence of DNA in the gene and sort of flips it off. So that's a super easy way to do it. When you get to more complex, like mammals, so doing an experiment in rodents and mice is much different. But anyways, so all we had to do was just spike their bacteria, and they would silence this gene.
So is that like changing the expression of the gene?
Totally, it silences it so that it's not expressed. So the gene is still there,
okay,
but it's not being expressed or it's not active.
Sure.
So exactly. And these worms lived 100% longer. So their normal lifespan is about 15 days. They went from living 15 days to 30 days. And when they were older, they were like healthy and active and moving around. And so it was like, wow, this is crazy. We have this gene, And so that kind of was like my first.
You're like, okay, this is what I want to do.
This is cool. Yeah. Like I want to understand this.
Wow. And so then you have to go to school even more to understand like cells on a micro level.
I mean, I did. I don't know if you have to.
Okay.
That's the path I chose. I decided I wanted to. I've always been, I'll set the bar higher for myself, and a little bit of a high achiever in that sense. So I decided I would get my PhD. And I went off to St. Jude Children's Research Hospital. I did pediatric cancer research for my PhD at University of Tennessee, which was the university that, gave me the degree, but I did all my research at St. Jude. And so from there I did metabolism, cancer metabolism, and understanding all of that. And then after my PhD, I did a postdoctoral training with Dr. Bruce Ames in Oakland. And there I studied more nutrition and the importance of micronutrients for preventing age-related diseases. And I was doing more clinical research with humans. So I kind of went from worms, and then my cancer research was in mice, and then I went from worms to mice to humans. And so that was...
Now is everything, when you say it's humans, is everything mostly tested on mice first for people who don't know anything about how that sort of stuff works? I mean, is that the natural progression?
Yeah, I mean, if you're talking about, looking at some kind of new treatment, absolutely. I mean, there's, you have to have preclinical studies.
It's mice. That's where it starts.
Sometimes they move to non-human primates, so like rhesus monkeys, and depending on, or sometimes they'll do ferrets, depending on what sort of treatment they're looking at. They try to see what, like if it's the immune system or something, they try to find an animal model that more closely resembles humans, fill in the blank, whatever we're looking at. So.
Sure.
But yeah, so my interests are really fitness and nutrition in how it basically pertains to the aging process. So preventative medicine, what we can do with our diet, with our lifestyle, to age the best way we can, to basically extend what's called our health span, which is the youthful part of our life. So it's like, well, we don't necessarily need to live to be 160, but if we're living to be about 80 or 82, we want to be physically fit. We want to be out surfing when we're 75 years old. We don't want to be in a wheelchair and degenerate and just aches and pains, and so that's kind of my focus. And of course, a lot of it's for selfish reasons, but also just because, I think that, a lot of people I care about, I see them, starting to crop up with age-related diseases. And
selfish is good.
It's awful.
The selfish is good. It's okay.
There is the selfish part, yes.
Selfish is good. I have this buddy, actually, who's like a real tech nerd, and he seems to believe that in the near future, we will we can extend our lives, double whatever it is. And I'm sort of, I scratch my head at that and I go, well, I don't even know if I really want to live that long, seeing everybody, your parents sort of pass away, and where are we medically, like when it comes to, rebuilding organs, or if something fails, like are we even there yet?
Well, I think we're definitely, in terms of regenerative medicine, stem cell research, we're making huge leaps. When I say we're, I mean the scientists actually doing that research, not myself included. But there's huge leaps that have been made just in the past decade, where now you can take essentially a skin cell. You're constantly sloughing off skin cells. You can take a skin cell from a person and give it this sort of concoction of certain genes, and it'll essentially turn that skin cell into a embryonic stem cell, which means now that stem cell, once you have an embryonic stem cell, you can put it in a certain environment with certain growth factors and cause it to become a neuron, or to become a heart cell, or a liver cell, or a kidney cell. So that's super cool, because one, you're not going to have this whole problem with your immune system rejecting someone else's transplanted cells, right? It's your own cell, so that's super cool. And the fact that we're there and can do that is really exciting. Mm-hmm. There's a lot of different things that need to be solved before it's used in the clinic, but that's definitely something that's currently being done in research right now. When it comes to like extending human lifespan or health span, you know, I don't know, if you think about it, there's centenarians, there's semi-super-centenarians, and then...
Explain for people who don't know what that is.
So a centenarian is someone who lives to be 100. A semi-super-centenarian is someone who's between 100 and 105. And then a super-centenarian is someone who's 105 and above. So like you get people to live to be 100 and, you know, 20. Mm-hmm. That's a super-centenarian. Well, if you think about it, so if the average lifespan in the United States of like a female is like 80,
wow,
then what's 120? Like that's a significant increase in lifespan, right?
Sure. And
some of these super centenarians, believe it or not, are more physically fit and healthy than 70-year-olds.
I know specifically. I mean, we're talking about my father. He's 87 years old. He looks like most 60-year-olds I see. He runs, works out, you know, is as sharp as a tack. And I don't know, this is actually, I was going to lead into this question because I don't know how much of that is genetic, you know, predisposition and how much, because he's taken excellent care of his body. I mean, he's crazy about what he eats. He has been for 50 plus years. You know, he doesn't drink heavily. He doesn't smoke. He doesn't do all the, you know, the no-nos. And he's just, you know, he's always been a health nut from an early age. Even in, I think in his 30s, he started really caring about what he put into his body. What's your opinion on how much of that would be genetics versus your lifestyle?
Yeah. I think that there's a combination of both factors that play a role for sure. You know, genetics unfortunately does play a really strong role in the sort of the capacity, like how far you can get in your lifespan, you know,
like out the gate,
like out the gate. Okay. Like okay, let's say, you know, you have the capacity to live to be 100, which not a lot of people do, but you have the genetics. Let's say you have, because we know now there are certain genes that can allow you to live to be 100.
Sure.
Unless if you have that, but you're also a heavy drinker, heavy smoker, and just you do all the wrong things, you may not like fulfill that. Like you may not live to be, you know, 100. But if you do, and you have all these, you know, really important, you do all the important things like exercise, you sleep, you avoid the refined sugar, you eat a lot of vegetables and, you know, micronutrients, you get all those things, then you're talking about not only living to be 100, but when you're up there in that 100-year range, you're going to be like a youthful 100, right? Yeah. So you're not going to be like, you know, wheelchair bound. But that's really great that your father's, first of all, I'm shocked that I know he was like 86 either.
Yeah.
The last time, I don't remember the last time I saw him in a movie, Gran Torino maybe, I think.
Gran Torino.
Probably.
It's the last movie.
But so how many years ago was that?
Well, he's been directing he's still been directing.
Right.
He just directed a movie about a year ago, or it came out actually a couple months ago, and he's doing another one. He's actually going to be acting in another one coming out.
But he was what, mid-70s when Gran Torino was filmed?
Yeah, Gran Torino was probably 10 years ago.
Was it?
Yeah. 10 years ago, something like that.
It's been that long. Okay, so
I was in it. I should know. I'm 32, so yeah, I was 21.
So running is a really important one. I mean, that's like, multiple things that's you know, improving your VO2 max.
What do you mean running? When you say running, like running?
You said he was a runner, right?
No, not specifically a runner. I just mean he is agile and he can go run, but he works out. He does.
Okay.
He's always weight trained. I don't know about specifically running. I mean, I know he does cardio.
Right.
Yeah, I guess
that's cardio.
Yeah.
What about high intensity, which is like sprinting or biking, really like at 80% your maximum oxygen intake?
I haven't seen him do that in a long time. I don't know if he did when he was younger. I love like good beach sprints.
Yeah.
You know, like I think it's great. I notice when I'm doing like beach sprints, the subsequent days after, I'll have more energy. I'll feel younger. I'll feel hornier. I'll feel like everything is, you know, and I've like really sort of getting like, I don't know if it's like testosterone boost, you know, but I feel, I do see like a big,
I've been really into the high intensity interval training, like would be sprints, hill sprints, beach sprints. I've personally been doing this interval training on a stationary bike.
Okay.
So kind of like a spin class, but it's not like, I hate saying spin class. I mean, really, it's like we have a trainer, and she's
it's a little more intense than a spin class.
Yeah,
you can kind of mail in a spin class.
Yeah. So, but it's really great. I mean, it's fantastic workout, and I feel so good after. So I've been digging into the science of it, because that's what I do. Like, when I really, I convince myself I need to do something, I'll dig into the science and I'm like, okay, I've got to do this, And there's studies now that have been done in humans showing that high intensity interval training can increase your mitochondrial function. So like by 70%. So I mean, mitochondria are what keep us young. Mitochondria are what produce energy. So you were talking about feeling more energetic.
Yeah.
Well, it's been shown that you can make new mitochondria from doing high intensity interval training, which is great. You want making new mitochondria. It's called mitochondrial biogenesis. Is one of the best things you can do to stay young. So
what does that actually do to the body?
So every cell in your body has mitochondria, have multiple mitochondria. And those mitochondria, as each hour and day and year go by, get damaged, they get older, become more non-functional. Okay. And that's how you're making energy. And so not only is it how you're making energy, it's also how you're making, as a byproduct of energy, things that can damage your cell, which are called reactive oxygen species, because
do they
free
protect
radicals.
It?
Free radicals. No. Reactive oxygen species are dangerous. They damage your DNA, cause mutations that lead to cancer. They damage your lipids, like the cholesterol in your cells, and make it stiff, and they do all sorts of damage.
So would that be like cigarette smoke, like carcinogen?
It does the same thing. It's kind of like a carcinogen, but it's not technically a carcinogen because it's something that's made in your body naturally, but it does the same thing that in essentially sort of similar way. Yeah, but that's kind of a good analogy to think of it. Yeah, exactly. So when you have new mitochondria, you're basically replacing all those old ones. I mean, it's rejuvenation. You're replacing those old ones with new, healthy, young mitochondria that are not damaged, that are more efficient, that can make energy, so
and that's specifically, you guys are finding it from high intensity.
Aerobic has been shown to do it as well. But but specifically high intensity, the study that I'm referring to where there was like nearly 70% boost in it, was high intensity interval training. And the other thing that's really cool with the high intensity is that it's been shown to boost your VO2 max. VO2 max is the ability to take in oxygen during exercise and transfer it to your muscles and tissues that are using it. Well, VO2 max is a marker of aging. Mitochondrial function is a marker of aging. We know that VO2 max declines by 10% per decade, so 1% per year.
So is that like when you're an 87-year-old's not going to be able to get in as much oxygen as quickly to...
Exactly. As a 40-year-old or 57-year-old, whatever. But here's the cool thing. There was a study, multiple studies that have looked at this, but one study in particular I'm referring to where 24 sessions of high-intensity interval training. The protocol was like a total of 45 minutes, and it was like a 5-minute warm-up, and then you had 4 1-minute interval, like high-intensity intervals that were separated by, I forgot how many minutes, but essentially something like that.
Some rest, yeah.
And it completely negated the 10% decline in VO2 max per decade. So it increased their VO2 max by 12% after 24 sessions. So you're essentially...
This is like take an older individual or someone who...
Or not, everyone. So we're all 1% per year. So yeah, so you talk about, let's say, because you already mentioned your father as an example, we'll just continue that. Yeah. He's 87, so you take him and you have him do 24 sessions of high intensity interval training, whether it's sprints or on a stationary bike or even swimming, whatever it is. Then he does 24 sessions and he essentially moved his VO2 max back to being a 77-year-old. Yeah.
Okay. But how long would you have to do that to
Great question.
sustain that?
Great question. I think that's something you'll sustain it, but you'll still continue to lose what you typically lose 1% per year. So if you don't continue doing the high intensity, then you're fine. You'll take yourself back a decade, but then you'll continue declining. But if you want to keep delaying the progression of the decline, then you just keep it up.
So now, with that sort of, theory, or maybe it's not theory, maybe it's fact now, if you started younger, if say you started at a 40-year-old doing that, would it keep you even further behind than starting at 70, or could you go back, say from 40 to 70, that's 30 years. Would you only be 10% behind?
In theory, if you started younger, you'd be better off.
Okay.
Theoretically, yeah.
Interesting.
Yeah.
Interesting.
So keep up your hill sprints.
Yeah. No, I love doing beach sprints because I think they're just I don't know why I noticed the benefits.
Yeah. Well, I've never really. This is sort of like the high intensity is sort of a new interest of mine. I've always been a runner, beach runner. Surfing was a thing, but actually now that I think about it, surfing. There's a component of high intensity to surfing, like when you're scratching to get over the wave. When you're paddling really hard, there's a set coming, and you're like,
Sure.
I've got to get over, or I'm gonna get, I'm gonna do donuts.
There's probably like a fight or flight thing too. Like if you're pushing yourself in bigger waves, and you're putting yourself in to more extreme situations where you're sort of innate.
You're pushing it beyond when high intensity basically is pushing it beyond the point when you can take in oxygen to fuel and make energy with your mitochondria. So you're basically you're not using your mitochondria at all to make energy. You're using another process called glycolysis, which is a little technical. I want to get into it, but with the surfing, you're going really fast because you're trying to like you said, you're trying to essentially get over that wave before it wipes you out. But it's funny because I remember thinking back then when I didn't understand any of these processes. I run all the time. Why am I so out of shape for this? Because I never
sprint thing.
Yeah, for this for this paddle sprint.
Sure,
it's why is it so hard for me? I'm like running 20 miles every 3 days or something like that.
Sure.
Back then I was a really long distance runner. And now I think back and I'm like, oh, I just wasn't doing the high intensity training that I needed to do. So it's possible that even would help someone like surfing.
Yeah, I'm gonna I think maybe start to add some more of that into my training.
Yeah, it's I'm super, like I said, I'm super into it right now. I also do the aerobic training, and strength training is also really important, preventing muscle atrophy,
Bone density, right?
Yeah. So those things are all super important.
Now, to switch gears just a little bit, just from a physical fitness to how dietary plays into that. If you're talking about these mitochondria and you're creating more by doing, like, say, this high, intensity training, what's going on like I guess from a 30,000 foot level with diet? Is that taking away if you're not eating the right food, or if you're getting better food, is that adding to that or taking away from that?
Yes. So your mitochondria require something that are called cofactors. Cofactors mean something that helps enzymes work. Enzymes are essentially what are running your metabolism,
Sure.
So that you can make energy. And cofactors are vitamins and minerals, essential fatty acids.
They keep those mitochondria like alive.
They keep them working efficiently. Yes.
Okay.
So you want things like the B vitamins. You want things like calcium and magnesium. You want to make sure you're getting the minerals and stuff. And these things are found really by eating a nice whole food, diet.
Sure.
Particularly a lot of vegetables. You can find a lot of really micronutrient dense vegetables like dark leafy greens, but also eating the good lean meats and stuff also
Sure.
have a lot of B vitamins and iron and all these things. These are all cofactors.
If for people who are listening and they're maybe not as versed in kind of healthy eating is kind of like a big scope to them, and they're like, I don't know where to start. Would you say that eating, if you have a healthy diet, you should be able to get all those vitamins from just food instead of vitamin supplements?
I think it's certainly possible to do that, but the question is, we don't really know how much of these micronutrients you need to optimize for longevity. I mean, we have what are called, these recommended daily allowances, right? RDAs. But those are based off of studies that are done in animals where they make an animal deficient in a certain vitamin or mineral, and then they find out, until that animal dies. And they say, okay, 2 standard deviations above that is the RDA. So it's like, okay, well, the RDAs are set to make sure we don't get some acute disease or, something that's going to lead to, something potentially like that could lead to death. But let's talk more like acute diseases like scurvy or beriberi, right? So you have a certain vitamin C requirement because you want to, you don't want to get scurvy. But we don't know how much of these vitamins and minerals that we actually need to keep all of our enzymes working optimally for, 80 or 90 years. We don't know. So there's something, and this is something that my mentor, Dr. Bruce Ames, really pioneered. He calls it the triage theory. What it essentially states is that throughout human evolution, humans have lived in various regions of the world, and depending on where you live, you have access to various foods, and they're different.
Sure.
Yeah, different diets, right?
Yeah.
And different temperatures and climates. So depending on where you're at, you may only get a certain type of food in the summertime and some in the winter, right?
If you're an Eskimo, you're probably eating a lot of, salmon or a lot of, fish with heavy oils.
Yeah. So basically there are periods throughout human evolution where you would be deficient in a certain micronutrient because you weren't getting the food that was rich in it because of whatever, the climate, et cetera. And so he has done some research and sort of proven on some of these minerals and vitamins that because multiple enzymes in your body can require the same micronutrient, the same mineral, for example. So let's say, for example, magnesium. Magnesium is found in dark leafy greens. It's required for all of your enzymes in your body that repair damage to DNA to prevent mutations, to prevent you from getting cancer. But it's also required by mitochondria in order to make and utilize energy. So he proposes that our body has this triage system that essentially processes that are important for short-term survival right now, like making energy. If you don't make energy, you die. They're going to get their pick of the mineral or vitamin first.
They're going to go first.
And the longevity ones, like repairing DNA, doesn't matter until you start to get into your 6th, 7th, 8th decade when cancer incidence goes up.
Sure.
So your body's like, well, you've already reproduced at that point. You've passed on your genes. I don't care if you get cancer. So the magnesium is going to go towards that process that's important for short-term survival. So the whole point I'm trying to make here is, well, you may be getting enough magnesium because you have the energy, but how are your DNA repair enzymes working? What does the RDA, we don't know. We don't know if the RDA is the best.
It's kind of like anything in diet. There's something always is changing, and we're always finding new stuff, is what you're saying?
Well, what I'm saying is that we, you asked if we can get enough of these micronutrients if we eat like a healthy diet and we don't have to supplement. And my answer to you is, let's define what enough of these micronutrients are. We don't really know. We have RDAs. The RDAs are set on, okay, this animal dies at this deficiency, let's go 2 standard deviations above that, and that's the RDA. Well, what some of us don't care about just not dying. We want to optimize for longevity.
Yeah.
So that's kind of what I'm saying. It's like, we don't really know. That's something that, and it's a complicated thing to sort of tease out. It's like human nutrition is really hard to study. So I do think it's best to eat a very varied diet where you're getting a wide spectrum of colors from your plants. You're getting healthy meats. You're getting the salmon, omega-3, like you mentioned. Mm-hmm. Things that like lean red meat in some cases once in a while is nice because you're getting a lot of iron. Right. And so, so eating a really varied, healthy diet, avoiding processed foods, avoiding refined sugars. I mean, these things are really, really...
The 3 white devils.
Is that what it's called?
He says bread, dairy, and refined sugar. That's what he says.
So I think that is really important. Personally, I try to do that, but I also do take certain supplements, which I think are really key for...
So you kind of have a varied diet. You try to slip in some red meat. You try to slip, you do a lot of
salmon, a lot of veggies.
A lot of veggies.
Yeah, I do
That's pretty much my diet.
Yeah, raw and sauteed, and so I do both.
My dad, very early on, he was like my mentor. So I keep going back to him for any sort of health related deals. He made me eat, like for breakfast, lunch, and dinner, pretty much was wild caught salmon, broccoli, And like if you wanted carbs, you'd be like maybe some sweet potatoes.
Dude, your dad sounds awesome.
I
Like
know.
he knew what was up like before.
I know, he really did. And he got me into it, like eating for nutrients, not for pleasure. Like he's like, eating is not meant to be
exactly
this great
That's
like
the whole
thing,
point, right?
You know?
That's the whole point.
But I think
nutrient
it's
delivery system. It's like
it's hard to get people off that though, because a lot of people get their pleasure from eating, and they think they associate that with this good feeling, this very short term good feeling, and so they don't think like that. And I think that's like a huge problem that we have in globally. Well, maybe not globally, but specifically here in the continental United States, because of like the fast food generation and what we've done. But
it's true. Can I just
yeah, please.
There's actually science. What you just said is there's science to prove it. So it's been shown that specifically refined sugar. So one of the white devil. What did you call it?
Three white devils.
White devils. Yeah. One of the white devils. Refined sugar actually increases dopamine, almost in a similar manner like
cocaine.
Yes.
Right?
Yes.
I read that the refined sugar. There's a Sugar Nation. I read that book.
Okay.
And I'm not familiar with it. It talks about that.
Yeah. So essentially, what you're talking about is people are addicted to their food because they're getting this dopamine response, like they get from smoking a cigarette, or maybe not essentially the same. I'm sure the magnitude is worse if you're taking cocaine or something. But the point is that you're activating the same reward pathways, and it's known that, for example, when you start to activate dopamine chronically like that, you downregulate or you decrease the amount of receptors that bind to dopamine, because your body's like, oh, I'm making so much dopamine, I don't need these receptors, which are important for the function of it. I'm going to get rid of some of them. But what ends up happening is that when you take that dopamine away, i.e. you're not smoking a cigarette or you're not eating your sugar, you start to have your baseline's much, much lower. You start to have a withdrawal, because it's like, even the little amount of dopamine that you're making, you don't feel it because those receptors are down. So you keep needing more and more. And so there's studies that have shown it takes about 3 months for your receptors to go back to normal. So for anyone that's trying to quit like cigarettes, for example, but my point is, I'm going back to the refined sugar. A lot of people have a hard time quitting it, but if they could just get past that 3 month
mark. Everywhere around us. Yeah. Everywhere we move.
If that's the baseline, then every time you ping it with sugar, are you basically just coming back to the baseline? Whereas then if you didn't have it, you would always feel as good.
Your baseline's going lower and lower.
Right.
So basically what's happening is you have a normal amount of dopamine receptors, and you make dopamine when you're out surfing, when you're having an interesting conversation, or you're with someone you care about, or whatever it is that stimulates you, right? You make a little bit of dopamine, and so you feel good. Well, when you start to make it above like normal, and you're doing it all the time, so you're starting to take some sort of like nicotine or some sort of drug or refined sugar, that's when your body responds, because there's feedback loops. Your biology is feedback loops. So it's like your body, you're making all this dopamine. So your body's like, oh, I don't need as many receptors. Receptors are important to have the function of dopamine, because I'm making so much of it. But then when you take away, when you're not smoking that cigarette, or you're not eating that candy, or Snickers bar or whatever it is, then the little bit of dopamine you make when you see your dog or your husband or your wife, it doesn't feel the same, because the receptors are less.
Wow.
So the baseline's lower. Yeah.
So how do you...
Go ahead, sorry.
How do you think that plays into... If I'm a healthy person, but, I like to, I got some almonds over there with sugar on them. They're just sitting on one next down. Anyways, but they have sugar and honey on them, right? And they're obviously delicious.
It tastes good, right? Yeah. The dopamine's going.
Yeah, dopamine's going. And I know they're not great for me. And I'm like, these aren't good, but once in a while I get into them, and once in a while I have candy bars and, whatever. How is doing that once in a while for people listening okay? Or is that a huge... Is there a disparity between someone who does it every day and someone who does it, let's say, twice a week and has like a piece, a Snickers bar or whatever? Mm-hmm. Is there a big difference when you're getting back to that baseline?
I would say that twice a week Snickers bar is not good. Definitely every day is that's
diabetes.
That's death sentence. I mean, that's very, very, very bad.
That's crazy.
But,
most people don't know that. Most people...
Yeah.
Go through
I
life.
only had one today.
Yeah.
You know, if you can do
soda,
like once
whatever.
in a while, like a once a month or once every couple of weeks, you know, I don't think it's that bad. Particularly if you're also, you know,
Healthy.
fitness.
Yeah.
You're getting you're otherwise eating your salmon and broccoli and, you know, sweet potatoes like you said, and you're doing your hill sprints and all that, or your beach sprints and all of that. Then it's not like such a big deal. You know, because the context is really important there. But most people are sedentary, you know, they're not eating all their, you know, salmon and broccoli and greens, and they're eating instead fast food and Snicker bars, and it's just a combination of bad, you know.
Sure.
So, and some people also can't just have one Snicker bars every couple of weeks or once a week, or, you know, because of that reward pathway. Now, so this genetics play a role too, because, you know, you have genetics regulating reward pathways and dopamine receptors and all, you know, so there's always a complex interaction between genetics and environment. So the way one person responds to something isn't necessarily the way another person's going to respond, right? Some people may be more susceptible to addiction, and so they may not be able to have that one Snicker bar like you can.
Let it go. Yeah.
Right. So, you know, things to think about.
I was listening to your latest podcast, and you guys were talking a lot about ketogenic diet, and I can't remember his name, who you were speaking with right now off the bat, but
Eric Verdon.
And he was talking about how he had, you know, tried a ketogenic diet. For those who don't know what ketogenic diet is mostly like a high fat, high protein diet.
Mostly high fat. I would say moderate to low
moderate
protein, and certainly very low carbohydrate.
And I'm gonna screw it up scientifically, but you correct me when I'm wrong. More or less, you're using these ketones for energy, right? Not glucose. And he was talking about how he doesn't know how realistic that is, like on a long-term basis. Do you practice ketogenic?
I personally don't. So
Have you tried it? Have you tried it?
Not really. I mean, so I haven't really like intentionally made an effort. So like I love vegetables and plants, and I love fruits and stuff, and that's the fruits like berries and pretty much can kick you out of ketosis. And so but I do eat, I mean, essentially if you look at the meals I eat, you know, salmon and broccoli, salmon and sauteed kale, salmon and some salad with olive oil, you know, so it could kind of be close. Sure. I eat a lot of avocados, but I haven't like made a real effort, you know. Also, I have some genes that predispose me to really, really high cholesterol because, you know, just one of these genes I have, which is called ApoE4. I have one allele of it. It's essentially like it makes my LDL cholesterol super, super high, which isn't necessarily a bad thing in and of itself, but you know, saturated fat increases LDL. So saturated fat is dairy, really fatty cuts of meat like pork, butter. You know, so those things are. I kind of limit. Coconut oil is also really high in saturated fat, so I limit that, and I'm more into the mono and polyunsaturated fat like salmon, nuts, olives, olive oil, avocados. Yeah. So those are more the fats that I choose to eat.
Do you take statins for anything? Or
No.
The doctor tried to put me on statins, and I was like, "That's all right. I'll try
what are
anything
statins?
else." The medication.
Yeah, statins. So basically,
for high blood pressure.
High cholesterol.
High cholesterol.
Yeah, you may have a genetic predisposition as well. A lot of people do have high LDL, and so the first thing that a doctor does is prescribe.
Try to stick you on some drugs.
The problem with statins are that they deplete something called CoQ10, ubiquinol, which is in mitochondria. And it completely depletes it, so you end up getting, for one, you can have muscle wasting. There are a variety of genes that regulate to what degree that happens. Some people have a 2-fold increased risk of having muscle wasting. Some people can have up to 15-fold increase from taking statins. So that's, you know, a concern, you know, because statins are essentially stopping your body from making cholesterol almost full stop for the most part. And you need cholesterol. Cholesterol is important. So, you know, it's just the problem is when the cholesterol gets metabolized into this other part of cholesterol that makes it smaller and more dense, and and guess what does that? Refined sugar. So don't eat your Snicker bars and exercise and everything. But yeah, so
for going back to the ketogenic diet, because you guys talked a lot about it on that episode, and I don't think I'm sort of like you. I've probably been in a state of ketosis at certain times. I just didn't know it, or it wasn't
fasting.
aware.
So that's when I do it is.
So that will put you in a state of ketosis?
So essentially there's two ways to get into a state of ketosis. The easiest and best way is fasting. So basically what happens is after about, I guess each person differs a little bit depending on how physically active you are.
Sure.
But like on average, after about 11 or 12 hours, your liver glycogen depletes, which means that you're basically going to shift from using glucose as a source of energy to using fatty acids. So you start to mobilize fatty acids from your adipose tissue, gets released, goes to the liver, and is used for energy, and you start making ketone bodies. And then the ketone bodies are transported to different tissues and are used as a source of energy. So I practice something called time-restricted eating, which is essentially trying to eat all my food within like a 10-hour time window. So I'm fasting for like 14 hours, overnight. But sometimes I do it for like eating within a 9-hour window. So I'm fasting for 15 hours. When I do that, I wake up in the morning and measure my blood ketones, and I can be in ketosis.
Yeah. On every day.
I haven't measured it every day, but like when I do when I eat within like a 9-hour window, I'll measure it,
Sure.
So being mild ketosis is like considered above 1 millimolar.
Okay.
And so I can do that for sure. The longer you're fasting, the more you'll go into ketosis. So people that are doing like a more extended fast, when they start to do 24 hours, 48 hours, they start to get into the 3, 4, 5 millimolar range of ketone bodies, and you're in ketosis. So that's another way to get in ketosis. In addition to
I've done the intermittent fasting. I've gone in and out of that for, I don't know, probably like 5 years. I've gone stretch, especially when I'm training for a movie or something. It's an easy way for, a month or two, a couple months to not eat in the morning until 12, have your first meal at 12 and your last meal at, 6 or whatever that is, 11 to 6 or something. And I don't always do like this morning. I just decided not to. Life kind of takes you where it was, and I was having breakfast with somebody. But do you find that the benefits of that are just as powerful as somebody saying like fasting for 72 hours, like once a month?
So there's different benefits from doing the time-restricted eating. The time-restricted eating has the benefit of basically your metabolism. You're eating when your metabolism is optimal, and when you start to like eat outside of that window, you're not as insulin responsive, so you're going to have higher blood glucose levels. Your fatty acid metabolism isn't as good, so you'll start to store more fat in your adipose tissue, and you basically will get fatter, so to speak, very scientifically speaking. But so the time restricted eating has your gut health is improved because your gut needs rest as well. So there's lots of benefits on a daily basis that time-restricted eating has.
Does it kind of reset your gut bacteria by not?
Your gut bacteria also are sort of on a circadian rhythm, so it does help in that sort of way, resetting your gut bacteria, so to speak, I guess.
If you do it for longer, like if you did like say a 5-day fast, would that really?
Well, so the fasting, the 5-day fasting, the benefits of that, and this is something. So the time restricted eating, the real expert on that is Dr. Sachin Panda at the Salk Institute, and I've done a couple of interviews with him on my podcast. But the prolonged fasting, where you're talking about 2, 3, 4, 5-day water fast, then you're talking about completely set of different benefits. So what ends up happening, and this has been work done by Dr. Walter Longo at USC. I've also talked to him on my podcast about this. This is where I've learned most of the research from these guys. But Walter has shown that what ends up happening is that when you hit about 3 days, you start to you clear away a lot of damaged stuff inside of your cells, called autophagy. But then when you start to hit 3-day mark, you actually like the whole cell itself. If it's a damaged cell, it dies. So you start to clear away all these damaged cells. They start dying, and they're replaced by new stem cells.
Hey, we're in the middle of something right now. Thanks. It's my assistant. She's coming over to pick up a car.
So what ends up happening is you clear away all those damaged cells, and they're replaced by new cells. But the way that happens is it activates stem cells. In fact, you can activate stem cell function by like 6-fold. So you start making new stem cells. So it's again a way to rejuvenate the body. So your immune system sort of like rejuvenated. And Walter has done a lot of work both in animals and also clinical studies showing this.
Is that like a survival instinct? It seems just like logically to me that if you're fasting, your body's starving itself, right? So is it going into like a survival instinct where it's sort of getting you to be a young, youthful person again? Like I'm dying.
It actually is going into this sort of survival mold. It's kind of a stress on the body, kind of like exercises or doing something like heat stress, like the sauna. It's a stress on the body, and the body responds in a way where it's like, oh my gosh, like I am like, this is like I'm gonna die.
Yeah.
So it kicks on all the stress response pathways. So all the antioxidant pathways, all the anti-inflammatory pathways, the stem cell function pathways, all the good stuff gets turned up because your body essentially is like, I don't want to die. So basically overcompensates for that little bit of stress. So this is often referred to as hormesis, where you basically can stress the body a little bit by fasting or by exercise or by polyphenols or by heat stress like the sauna or hot yoga or a hot tub.
And I've heard a lot about you talking about the heat stresses. Yeah. That is what you say, and correct me when I'm wrong, is that forms a heat cell protein that preserves the cell, right?
Heat shock protein. Yeah, the heat shock proteins. Yeah, it basically protects the cell. Yeah, it protects it from damage and things like that. So, but yes, the sauna is another form of like a hormetic stress where it activates all these, stress response pathways.
Is sauna better than steam?
Well, the sauna is where most of the research has been done. So I don't know if it's better than steam. I just know that we don't have a lot of the empirical evidence to make the same claims from steam. Right. But essentially, the important point is the heat stress. And when you're in the sauna or you're in a hot tub or a hot bath or you're in a steam shower, you feel the same sort of uncomfortable feeling, and your heart rate starts to elevate. In fact, heart rate goes up to like moderate physical activity level. And a lot of the benefits from heat stress mimic physical exercise, cardiovascular exercise. If you think about it, when you're doing aerobic exercise, you get hot, your core body temperature is elevated. Yeah. So there's an overlap there with these systems. And a lot of the research that's come out of Finland from Dr. Jari Laukkanen, his lab has done these huge observational studies because in Finland, like, saunas are just so ubiquitous. I mean, they're just everywhere.
Yeah, and I love it. I get in 5 times a week.
Do you? That's awesome.
Yeah.
I recently, a couple of years ago, I went to Finland and so I'd had the whole Finnish sauna experience, and I met with Jari and talked about his research with him. And he's shown that, for example, men in Finland who use the sauna so if they use the sauna like 2 to 3 times a week, they have a 24% lower cardiovascular disease risk. If they use the sauna 4 to 7 times a week, they have a 50% lower cardiovascular disease risk compared to men who only use it once a week. Amazing. Not only that, he's shown that dementia is also staved off. So men that use it like 4 to 7 times a week have a 60% lower risk of getting Alzheimer's disease and dementia, around 60% lower Alzheimer's disease and dementia compared to men that use it 1 time a week. So
how long was the study on this?
This was a 20-year follow-up.
Wow.
The 20-year follow-up. Yeah. And in Finland, like I said, everyone's got a sauna. Almost everyone has a sauna in their house. It's so common. They have these public saunas that people go. They have co-ed ones. They have ones that are, just for certain genders. And so it's really great. The sauna culture there is certainly nothing like here in the United States, where it's like, oh, it's at a YMCA.
You guys have a sauna. You guys
right.
have a sauna here. Oh, wow.
You'll find some like really old buildings, like condominium complexes or apartment complexes that were built like I don't know, 70s. They have saunas in the building, but it was like, it's like a dying thing in the United States. It's kind of coming back now.
With some of the health resurgence of it all. Going back to the fasting, just because I wanted to ask a question about it. What's the where does it become unhealthy? Like, what's the, if we're talking like 3 to 5 days of fasting, and after 3 days, there's significant benefits to, the cells and to killing off the cells. What becomes, from a medical standpoint, what becomes an unhealthy, like too long to fast?
Well, one thing to keep in mind is that like fasting probably, it's not for everyone to just try. Some people who can have low blood sugar, can be hypoglycemic. I mean, there's a lot of dangers to fasting. So it's something that, you need to be really cautious about. And, I would say to some degree, medical supervision, So that's, that's definitely something to keep in mind if you have like some sort of underlying disease condition, like at all, like, like fasting is something that's, it's a stress on the body for sure. So that, and now in terms of like,
but if you're like a healthy person,
the question is how long can you fast before it's unhealthy, or when it's unhealthy?
Like where is the inflection point of, okay, this is healthy, 3 to 4 days, 5 days, whatever.
Yeah.
And then, okay, I know, because I know people there's people who fast for like 8, 10 days. I mean,
Well, Valter's research sort of has put like, the 4 to 5 day cap on it for a reason, where it's kind of like, okay, at that point, you need to refeed, and the refeeding part is important because you have to like
do it right.
If you refeed, that's when you get your whole stem cells, because you need to proliferate and have them grow.
Yeah.
And if you keep fasting, you're going to clear away all those damaged cells, but the stem cells need to get activated, and you need to have them growing, and they need food and energy to do that. Now, obviously, some people that are like morbidly obese use fasting as a means to lose fat, and they, I have a friend, for example, that has lost a couple 100 pounds, and he was at his worst like 400 pounds, and he's been doing these like he has done a few of like 20-day fasts.
20 days,
but he's got a lot of fat. He's got a lot of fat to burn.
Wow.
So
that actually matters. The actual physical amount of it in comparison to
if you're talking
who's tiny.
Yes. If you're talking about going out for extended long periods, now that is something that I would say that's an extreme case of fasting.
Sure.
But it is this particular friend that I'm referring to has tried so many different things to lose low carb, ketogenic. I mean, just everything,
and nothing
would work except for just not eating. When he stopped eating, he started losing the fat. Like, and it's amazing to see him have dropped like 200 pounds over the course of 1 year.
But then I've always heard, and maybe this is just like sort of, old wives' tale, that people would do that and then they would gain the weight back when they'd start eating again. So I'm sure there has to be like a...
But he continually does the fasting. So the thing with him, and I try to get on his case about this because I'm all about quality of the food.
Sure.
It's very important.
Yeah.
Micronutrients and all these things we talked about.
Yeah.
But he's a foodie, and he gets the dopamine, and he likes, he likes eating his tasty foods that aren't necessarily good for you. But what he does is he'll do, a week fast once a month, where he just 5-day fast, and so
does he fluctuate, or is he has he leveled off?
Well, I think more recently he's done like he wasn't doing as many of the fasts or something, and so he kind of fluctuated. But for the most part, if he keeps the fast up, then he can keep the weight off.
Wow.
But again, I think for anyone that's going to try to do a water fast, it's really there are a lot of things to keep in mind. Like you need to get minerals and salts and all these things.
Yeah, because if you don't have salt, you'll die, right?
So Dr. Valter Longo has developed a what he calls a fasting mimicking diet. And it's a diet that has a certain amount of, it's the macronutrient breakdown. So the carbohydrate, the fat, and the protein content has been figured out to kind of mimic the effects of fasting. And he's published many studies, both in animals and also in humans, to show that a lot of the effects are the same. So he's got this fasting mimicking diet that sort of helps people transition, because a lot of people have a hard time not eating for 4 or 5 days.
Yeah.
And it certainly can be more dangerous. And so having some little bit of food can help. But his, like I said, his diet has a certain ratio of all these macronutrients that are really important. And also there's a calorie cap on each day. So that's called the fasting mimicking diet.
That's really interesting. And I might mention your friend, or I might just tell my friend who was on some pharmaceutical drugs to help depression, bipolar disorder, and they made her gain a lot of weight. And she was on them for, I think they're like an injectable medication. You probably would know better what sort of they were, but they made her gain a lot of weight in a short period of time, over like a course of a year or something. And now she got off of them, and she's having a very hard time losing the weight. She always was, in good health, but she ballooned up, and I don't know if it's affected her metabolism in such a way where it doesn't process the same anymore. Yeah,
there have been studies looking at a variety of different psychotropic drugs that are changing, altering chemistry, brain chemistry, and anti-anxiety to help with depression, things like that.
I mean, the drugs actually really helped her become more lucid and more sane about, some, things she was doing, but they've really affected her health.
Yeah, so that's one major side effect that's known of some of these drugs, and ultimately they're changing a variety of different things, hormones. So hormones that regulate hunger, hormones that regulate satiety, so making you feel full, hormones that are regulating the way your insulin response is occurring. So a lot of these things are altered, and sometimes it does take a while for things to reset. Like I was saying, 3 months, sometimes it's like 3 months or more. So I don't know specifically in this case, but it is definitely a side effect with some of these psychotropic drugs, changing metabolism and predisposing people to gain more weight, and also even to, unfortunately, metabolic syndrome. So
when you talk about the micronutrients, and I've heard you talk about them a few times, I think on Rogan, about, is it growing these certain microgreens, like baby version, pretty much baby broccoli, right?
Broccoli sprouts.
Yeah. Can you tell me about that?
Broccoli sprouts are amazing. Yeah. So cruciferous vegetables, which are the family that broccoli is in, they all have something in common, and that is they have a precursor to make something called sulforaphane. And sulforaphane is, like, people can think of it as a quote-unquote superfood, but it's much more than that. But essentially, what sulforaphane is we were talking about hormesis earlier, about fasting and exercise and how these things stress the body. And as a response, your body ramps up all the anti-stress pathways, right? And so you overcompensate, and net, there's a positive effect, right? It's how exercise and fasting help. Well, plant compounds have something similar. They make a lot of these polyphenols and things. If you think about plants, well, when you have an insect come bite a plant tissue, the plant's going to make something to kind of ward off the insect. And a lot of these polyphenols, that's their function, like resveratrol, sulforaphane. They actually ward off the insect because they're slightly toxic. When humans take them in, it also stresses the body in a little bit of it causes, it's called a plant hormetic compound, and it's slightly stressing the body a little bit, and so your body ramps up all these anti-stress pathways, much like fasting and much like exercise in the same way. So sulforaphane is one very powerful one that ramps up a pathway called NRF2, which essentially causes you to make a lot more antioxidant pathways, anti-inflammatory pathways, stem cell function, just all sorts of good things.
NRF2.
Yeah. So sulforaphane is found, and if you think about it, young plants, biology always wants to protect young plants more because they haven't passed on their genes, they haven't reproduced.
Sure.
And so the young plants always have higher concentrations of
when they're the most healthiest, right? They're like,
Yeah. So broccoli sprouts, which are the immature broccoli plant, have a really, really high content of this precursor. It's called glucoraphanin. Glucoraphanin, once the plant cell wall is broken, so when you chew it, the broccoli sprout, or you blend it, or you chop it. No. So you have to cut the tissue. You cut the tissue. Then this enzyme gets released that converts glucoraphanin into sulforaphane. The enzyme that does that is heat sensitive. So when you boil it,
kills the enzymes.
That's
where I was kind of going.
Yes.
Is that because you can steam broccoli, but are you pretty much getting
You're getting a little,
very little bit of the nutrient value to it.
Yeah, well, of the sulforaphane in particular.
Okay.
So that's one of the problems with, but you're getting a lot of other good stuff from broccoli still that are
fiber and this, that,
and the
right?
magnesium and folate and all that. Yeah, and fiber, but yeah. So if you're boiling the cruciferous vegetables like broccoli or cauliflower or cabbage or Brussels sprouts, then you are going to kill that enzyme to some degree. Now what you can do is add back something that has the enzyme, like mustard powder. So if you sprinkle mustard powder on after you're cooked your cruciferous vegetable, mustard powder is also from the cruciferous family, mustard seed. It has the active enzyme. And so you add it back, and then you can convert a little bit more of that glucoraphanin into sulforaphane.
Not the entire, though.
It won't be as good as eating broccoli sprouts.
Raw is the best.
Raw is the best to get the sulforaphane, yeah.
Got it.
And broccoli sprouts is the king for that.
Sulforaphane.
Yeah, and so there's been a lot of human studies with sulforaphane showing that, for example, people that take the broccoli sprouts, even after just one time, start to excrete through their urine carcinogens like benzene and acrolein, which we take in breathing air pollution. So in LA, for example, or obviously if you're a smoker, then you're getting tons of benzene. If you're a smoker, you should definitely quit smoking. But if you can't quit, eat the broccoli sprouts by the pound. So they excrete it by like 60% after just even one time. So that's real, and that's getting rid of toxic things. But it also increases antioxidant enzymes in people's blood cells, by, I don't remember the percentage, like 24 or 25%. It's been shown, to help with brain function. Autistics that were given sulforaphane, they dramatically improved their autistic scores.
Wow.
It's been shown to improve, markers of cardiovascular disease in humans. So oxidized LDL, triglycerides, all these things. So it's pretty awesome.
Now, what's the best way for people who, aren't maybe necessarily growing broccoli in their yard, right?
You can grow it in your kitchen. It's really easy. You just get some broccoli seeds, a mason jar with a lid that has a little strainer on it.
Sure.
Put the seeds in, add some water, soak it for 6 hours, and then rinse them twice a day. No dirt. Rinse them twice a day, and third day you harvest them. They'll sprout right in the mason jar.
Wow.
And
in your fridge?
And then you put it in your fridge after. So this is on the kitchen counter, and then you can put them in the fridge. So you keep on a neutral temp kitchen counter, move them to the fridge once they've sprouted. Yeah.
And then how long are they good for?
I mean, in the fridge, a few days, probably like 3 or 4 days.
3 days.
You can throw them on your salads. You can make a smoothie with them.
Now, how much of these per meal or whatever are you trying to ingest?
I mean, typically when I was doing a lot of it, I was taking in probably like 75 grams.
What is that? How much is that? Like in a
big handful,
big handful of them?
Big old handful, yeah.
Okay, and just tossing them in a salad, boom.
Yeah, or I was actually tossing them in the blender and drinking it. Just kind of like taking a shot.
Yeah, you're getting it over with. Getting your veggies in.
Yeah,
for sure.
So yeah, it's really easy to grow. I mean, essentially cheap.
That's great. I know I got to start doing that because I read about that. I mean, I listened to you on Joe Rogan. You were saying that. I was like, oh my god! I was like, I got to do that.
I haven't been doing them, since I was pregnant because the potential for contamination, like E. coli contamination, and then now that I'm breastfeeding, I still.
How is that? Are those more susceptible to E. coli than broccoli you'd get at, let's say, Whole Foods? Or
sprouts are. Yeah, sprouts are susceptible to it because you're growing them and you have water,
bacteria.
Yeah, so this is something like broccoli. Broccoli's growing out in the garden, and this is something that's being grown. Like the broccoli
in a petri
sprouts,
dish, really.
Essentially, it gets in a jar. Yeah, so it's like it's really easy to contaminate. Now, I have had a bad experience with broccoli sprouts that were store bought from Sprouts.
Really?
Store, because I really wanted some, and we didn't have a harvest yet, so I went and bought some, and I ate the whole package in one. I put the whole package in my salad, and I ate it, and I was like super sick to my stomach nauseous, and I was
sure.
Yeah, so.
So what's the way to make sure you don't do that if you're growing them yourself?
Well, I think there's a few things you can do. One, buy organic seeds. Make sure you have a sterile environment. Like you want to sterilize your mason jar with hot water and everything. Make sure it's clean. Sure. Also, make sure that you don't have. There's not a lot of heat, because
too hot in the sun sitting.
Right, because then you're making more condensation. So when you're rinsing the seeds, you want to get all the water out, and then because water can that can help bacteria grow and stuff. So that would be, and then the early harvest after the end of the second day, beginning of the third day, you just put it in the fridge. So you stop the whole process, right?
How big are they at that point when they're?
You should go on my Instagram. I have photos. Yeah, photos of my mason jars. We have a whole a dense jar of it. That's just the mason jar is just full of it.
Okay.
So completely full.
Wow.
It's super dense.
Yeah, I'm gonna get on.
But it all depends on how many seeds you add. So we're right now we're adding 9 tablespoons, which is a lot. But because we're doing a really short grow protocol, 3 days. The more seeds you add, the more dense you're going to have. So the more broccoli sprouts you get.
Got it. With all the smoking talk, I wonder, what's your opinion on all these new e-cigarettes?
I mean, I've read some studies. Well, I should say I've more skimmed them. I've really not read them. Showing that there's, less of these carcinogens that are found typically in just normal cigarettes. So that's a good thing, right? So you're getting less of the benzene, and
sure.
and that's definitely good because benzene.
Well, it's propylene glycol, right? In many cases, and vegetable glycerin, right? For these flavorings, at least what I've read. And then nicotine. If they are adding nicotine or not,
right?
Is the nicotine have the benzene in it as well?
No.
It doesn't.
It shouldn't. I mean, the benzene, yeah. So the nicotine, though, but the thing about the nicotine is, you're chronically activating your nicotinic receptors, and the same thing we're talking about baseline going lower. And so, I mean, you'll have an acute effect of sometimes you can have more focus and clarity and things like that. But then once the nicotine's gone, in fact, it helps with things like what's called sensory gating. So sensory gating is the ability to filter out all these things that are going on around to focus. We're having a conversation, but there's stuff going on around, but we're not focusing on it, right? People that have, for example, schizophrenia, they have a real problem with being able to do that. So they're constantly everything all in at once, and it's overwhelming, and so they get the sensory overload, and so oftentimes they can't be in big group places, Sure. Nicotine actually helps totally normalize
Focus
that. It helps that, and it's often the possible reason why schizophrenics are chain smokers, because there's a 15-minute time period where it helps with sensory gating, and within that 15 minutes they're able to handle it normal, a normal person in a way. But then after 15 minutes it's back to overwhelmed, then
you're depleted, back low,
and so you have to light up another cigarette again to so it's kind of interesting because a lot of people that are schizophrenic are also chain smokers, where they're just constantly
sitting with an ex-smoker.
Yeah, so it does help with that, being able to focus in a sense by helping you even filter out a lot of that stuff.
Do they know what it is in the nicotine that provides that, so that something else could be given?
Well, it's being that's a great question. So it's stimulating a specific receptor in the brain, the alpha nicotinic receptor subset 7, and nicotine stimulates that. The other thing that can stimulate it is choline. Interestingly, so
what is that?
Choline is a nutrient that is found in egg yolk. It's found in lecithin, soy, plants and stuff have it. But so choline is a really important. It's important for a lot of reasons. It's important for brain development. It's important for making phospholipids. It's important for brain function as well, and making acetylcholine, which is a neurotransmitter. So it's interesting. A lot of people actually take choline supplements in some form or another. There's a variety of different ways you can get choline. It's in a phospholipid form, or it's in this other form, or fill in the blank form.
Right.
But people are taking it as a nootropic, smart drugs. So I've often thought, can you take, and this is complete speculation, there's no evidence. I've often wondered, can you give someone a choline supplement to help them quit smoking because you're stimulating the same receptors? Can you get some of the same effects because the choline acts on the same receptor as the nicotine does? The reason it's called a nicotinic receptor is because nicotine is the strongest agonist for it, meaning it activates it the best, but choline does as well. So yeah.
I find that I feel like a similar way with coffee and caffeine. Whereas I go in and out of drinking coffee. Like I'll go off caffeine for like 6 months and I won't have any caffeine. And I find, and then I'll get sort of roped back into it.
Yeah.
I find that when I'm off of it, I have more sustained energy throughout the day. I might, be, a little slower in the morning and have to like build up to whatever I'm doing, or, getting that cheat shot of coffee might, kind of jumpstart you, but I'll have more sustained energy when I go on caffeine. I'll get the high, at the spike of the caffeine, but then I get a low.
Right.
And is that acting the same sort of way, like where it's depleting the dopamine and you're going like, okay, I need this caffeine high? Does caffeine work the same way?
I don't know. I haven't looked into the effects on how caffeine affects the dopamine system, but caffeine does a variety of other things. So it blocks another receptor called the adenosine receptor, and adenosine is something that makes you sleepy. So it's kind of an immediate like, oh, you're tricking your brain. You're tricking your brain. I'm not sleepy. I'm awake. And so adenosine also has sort of a calming effect. So you're not getting that like...
that calming, sustained...
You're not getting that, yeah.
Yeah, sometimes I feel like a little anxious on coffee, depending on if I've eaten food with it or not.
How much you've taken, how much... Yeah, right, yeah. So that, there's probably a variety of factors that can regulate that. People metabolize caffeine at different rates depending on their genetics. But in addition, there's some interesting research looking at cortisol and how your cortisol, which is a stress hormone, how that changes in response to caffeine intake. So cortisol, the way it works is that you usually make most of the cortisol first thing in the morning when you're waking up, early morning hours. And that's kind of like your body's way of saying, wake up, it's time to wake up. So you get that surge of cortisol. What you don't want is to have constant surges of cortisol throughout the day. I mean, it's a stress hormone. So you do make cortisol when you have some sort of, stress that you're experiencing, social stress, psychological stress, whatever. You can make cortisol for those reasons. But there is some evidence that caffeine may sort of change that, and you may make cortisol like at an off time point where you're not normally supposed to make it.
Because maybe you're supplementing the coffee with it, so you're getting...
something like, it's changing
less cortisol.
Yeah, I don't know exactly the mechanisms, and I'm not even sure if that's well understood. But yeah, essentially, you're instead of the cortisol waking up first thing in the morning, you're like getting that coffee, and it's kind of like so that the whole like thing is shifting. Your cortisol response is kind of shifting. And anyways, I don't know enough about it to speak like an expert, but there's definitely some changes. That's all I do know for sure. It's changing it in a way.
Are you a coffee drinker?
I am a coffee drinker. Yeah, I didn't drink any coffee my entire pregnancy. I completely quit. I quit. And then
was it hard to quit? Did you find it being hard?
It was hard for like it was hard for the first week when I did get a caffeine headache and things like that. But the hard thing is that I just love the taste of coffee.
Sure.
And so, like my husband was still drinking it and I'd smell it and it was just like, But and then I didn't add it back until my son was about 3 months old, because at about 3 months, he's able to metabolize caffeine. You do transmit a little bit of caffeine through your breast milk, and they can metabolize it a lot better at 3 months.
Got it.
But it's like, sleep deprived, and it's like, I'm just like, at some point, I was like, I first was like half a cup, and then I was like, I just need a cup of coffee,
Sure.
It is my drug of choice. I do love caffeine, and I do feel like it.
I think it's most people's.
Yeah, it's, but there's been studies looking at, for example, telomeres, which are a marker for aging. Mm-hmm. So telomeres are what they basically protect your DNA from damage, but telomeres get shorter every year. So every year we lose like 24 nucleotides off of our telomeres, and so someone who's 20 years old has much longer telomeres than someone who's 80 years old. There's things you can do to delay that shortening: exercise, sleep, getting enough vitamin D, omega-3, these things all shown to delay the shortening. Though interestingly, caffeine has also been shown to increase telomere length or delay the shortening as well. Yeah, surprisingly. And this is multiple studies showing this now. So, and it was actually specifically caffeine, because they looked at decaf and caffeinated coffee, because there's polyphenols in coffee as well, beneficial ones. So it was actually specifically, believe it or not, and I was completely shocked. It was the caffeine. So I mean, there's definitely there's evidence that caffeine can be beneficial, and there's also lots of evidence showing it lowers type 2 diabetes risk and lots of other things. But like you said, there's this other possible change in the hormones, stress hormones, and feeling more anxious, and so I think that it's sort of, there's a blurred line there. Like, I don't know.
Yeah, I really notice. Going to sleep, to the topic of sleep. It's like when if I have any caffeine past a certain hour, it proves a lot harder to get to sleep.
Me too.
And
absolutely. Yeah, like if I drink it like afternoon 1, it's
gonna really fuck me up.
Right. Yeah, exactly. And that also has to do with the way you metabolize caffeine. People metabolize it different. I'm a slow metabolizer. Yeah. So I've looked at, there's ways you can get like your gene polymorphisms looked at, which are just variations in the sequence of DNA. 23andMe is a service that I use, but
I've never done that. Did it prove to be pretty useful?
So 23andMe, they'll basically measure about 55,000 different DNA sequences, and they have 2 different tests you can do, like their ancestry test, which is like $100. And they tell you about like where you're from.
Yeah.
And then there's their health report test, which is $200, and they give you some health information. I did the $100 ancestry one, and then there's different services you can use. So like I personally have developed a genetic tool that I've looked at various genes that are really important for like nutrition, fat metabolism, vitamin, micronutrient intake, and I help people interpret that. So if they've done 23andMe, they can use my tool. Another service that's really good is Promethease, which gives you tons and tons and tons of great information based off of your 23andMe, because the 23andMe will give you your raw data. But so all that caffeine metabolism and stuff I got from using Promethease.
Did it tell you like, hey, you're a slow metabolizer of caffeine?
Yeah.
Wow, that's that granular.
Yeah.
Wow.
Yeah. It tells you all sorts of interesting things. You've got this dopamine change. You're more likely to be, you're basically making less dopamine. So so it's lots of different interesting things.
It's interesting. I think my buddy just did it, and he said that he produces too much estrogen, and so he had these estrogen blockers.
Well, the best thing to do with any genetic test is always follow it up with a blood test, because genetics is very complicated, and just because a certain gene says one thing, it doesn't mean there's lots of genes
factors that do, and things as well.
Yeah, that also there's a lot of redundancy, meaning that lots of genes regulate the same thing. So just because one gene says you make less estrogen, there's lots of genes that are making that. So the best thing to do would be to get a blood test and have your testosterone and estrogen and estradiol and all the metabolites measured.
And maybe he did that. I don't know.
Because the last thing you want to do is
just
make
be taking estrogen blockers.
Right.
Yeah, I don't know. Would an estrogen blocker, does it even work?
I don't know. I'm always, really wary to mess around with hormones, when you start to do that. So
yeah,
it's kind of a last resort sort of thing.
That's I have to get that done. Have you done that, Tim?
Nope, I've not.
For 2 seconds, I've got a couple other questions I had for you. That were some interesting ones.
Dairy, you were talking about breastfeeding your son.
Mm-hmm.
There's a lot of talk, at least in vegan and vegetarian circles, about nobody has dairy after a certain age, and we're the only animal being that drinks another being's milk. Are you a fan of dairy? Is it something that you think is just early life kinds of thing, or what?
Yeah, so I mean, personally, the gene that regulates, the ability to digest lactose, the lactase gene, it essentially is active during early infancy, and then it's turned off. Like you said, it's turned off. The gene gets turned off, like epigenetically turned off, and so a lot of people can't process lactose anymore and become lactose intolerant. Now, that's all depends on genetics. So like I personally am not lactose intolerant. I still have my gene. So again, this comes down to, everyone's sort of genes are a little bit different and you respond differently to different things. Well, lactose is one of those sort of classical examples of what's called nutrigenomics, the interactions between genes and diet throughout human evolution, depending on where the theory is depending on where your ancestors are from. If you're from a more like farming agricultural part where you were drinking cow's milk, that over generations, eventually you retain the ability to keep that lactase gene on, and so that you can digest lactose. And that's essentially what has happened. A lot of people can digest lactose. A lot of people still can't. But so yeah, there is definitely a genetic variation and variability from person to person. Personally, there are some benefits from eating dairy, like the calcium, for example. Definitely, I think that would be the main one. Other than that, it's definitely a saturated fat, and a lot of people, it does make an allergy. Like my husband, he gets eczema from dairy, too much dairy. So he and I've cut it out recently as well. So
it's weird. I've gone in and out and cutting it out because I think I'm mildly lactose intolerant. And then when I cut it out completely, if I do get it, it's like, oh my God, and I'm like run to the bathroom. Whereas if I've had it, sort of in my diet, like in and out, it doesn't affect me as much.
There's also changes in your gut microbiome depending on what you eat, and dairy is very saturated fat. When you're not used to eating a lot of saturated fat, and then you introduce it to your gut, it becomes very hard on the gut. But when a person that's constantly eating saturated fat, their gut gets more used to it, to saturated fat. And I'm not getting into all the science part of it, but that's essentially what happens. So that's why, like, when people are really clean, healthy eaters, and then they like go eat like a really like greasy like meat, they feel like crap. But like someone who's always like eating that, they're like, "What's wrong with you?" It's just pizza.
Soft.
Yeah. So. Yeah.
Is there a good alternative for calcium?
Well, a lot of greens have calcium as well, but I would say that you'd have to eat a lot of greens, a lot of leafy greens for sure. But believe it or not, they do actually have a decent amount of calcium in them. But you can also get your calcium levels measured just to make sure. The other thing is that it's not just getting the calcium, it's absorbing the calcium. So one of the major regulators of calcium absorption is vitamin D. So people that have adequate levels of vitamin D, which are considered around 30 nanograms per milliliter or more, absorb 40% more dietary calcium. So if you're vitamin D deficient and you're not eating dairy and you're not getting greens, you're probably not getting enough calcium. But if you have adequate levels of vitamin D, then, so for example, I eat a lot of dark leafy greens, and I take a vitamin D supplement as well. So, I'm definitely, not vitamin D deficient. My vitamin D levels hover around 50 nanograms per mil. And so I'm absorbing 40% more calcium than someone who is eating the exact same diet as me, but is vitamin D deficient. So that also makes a big difference. And then on top of that, you want the calcium to go to the right place. You want it to go to your bones. You want it to go to your muscles, because calcium is also a cofactor for enzymes, not only used for bones. And what regulates that is your vitamin K, because vitamin K is really important for making sure that the calcium that you do absorb goes to your bones, goes to your muscles. Specifically vitamin K2, which is found in like fermented food, like natto is a really good source of it. No one here in the West eats natto.
Don't even know what it is. What is natto?
Fermented soybean, big in Japan.
Okay.
You can find it in small amounts in like fermented foods like sauerkraut, but you also can take Kombucha, a little bit, yeah. You have the bacteria that make vitamin K2 also in your gut as well. But if you get enough vitamin K1, which is found in dark leafy greens, vitamin K1 predominantly goes to the liver first. But if you're getting enough of it, going back to the whole triage theory, goes to the liver first. But if you have enough of it, then after it goes to the liver, it stays in the bloodstream, and that's where it helps shuttle the calcium
for longevity.
Yeah. So dark leafy greens, vitamin K1 can also do what vitamin K2 does, but you have to make sure you're getting enough of it, if that makes sense.
Got it. As far as supplements go, for people that are listening, I find it so hard to know what is bullshit, what's not. And especially, even if you know, like, okay, I'm vitamin D deficient or I'm X deficient, how do you find a good supplement company that's not just using a bunch of filler and a bunch of bullshit?
Right.
You know, and you're actually maximizing the most in that pill.
It's a great question. I mean, unfortunately, there is a lot of clover leaf and filler and bullshit, as you said, in vitamin supplements. They're not regulated at all.
Yeah.
You know, there's a handful of supplement brands that I've used and have been validated by colleagues of mine or scientist friends that have
been to the factories or
just taken their supplements and like run them on an HPLC and said,
wow.
oh, this actually does have what it says it has.
Oh wow.
But there are some companies like the National Sanitary Foundation, NSF. Their website, they usually have a list of brands. When we're talking about fish oil, there's the international.
They're a good list. They offer a good list.
Well, when you have something that is NSF verified, the NSF goes to the facility, checks it out, makes sure it's sanitary, and they look at certain things to make sure that the company is like legit and doing what they're supposed to say they're doing
up to a certain standard.
Right, exactly. Yeah. And then there's other like companies like Labdoor that are like independently verifying various supplements. How reliable those companies are, I don't know, but they are out there. They exist. Personally, the brands that I have found to be reliable, just based off of knowledge from scientists that have used them and like actually measured what's in some of their supplements, are Thorne. Thorne is really reliable. By the way, I have no affiliation with any supplement companies. I just use the ones that I think are high quality.
Sure.
So Thorne is a really good brand. Pure Encapsulations is also another really good brand.
Thorne.
Yeah, Thorne is really good. Life Extension's pretty decent as well. Life Extension.
I think I've had several supplements.
Jarro's pretty decent, but Thorne and Pure Encapsulations are my top two. They're like the highest quality. Unfortunately, they're also pretty expensive, but they actually like have what they say they have in their supplements.
Is in there. What do you think about? I talk to a lot, especially because I'm in Southern California, and a lot of vegetarians, and they're like. And I'm like, aren't you iron deficient? And they're like, no, I take iron pills. Oh my God, I take so many iron pills.
Oh no.
And I'm like, I think you're anemic. I think you're anemic because there's bruises all over your body.
Uh-huh.
And I always hear vegetarians say that. And I'm always like, I don't think you can get as much iron as you think from purely a supplement. Is that
It's true.
Is that true?
Yeah, it is. Yeah. So not only a supplement, from plant sources. So plant sources, there's iron that is bound to what's called phytate, which are found in plants like spinach. Spinach is a great source of
plant iron.
Of plant iron, right?
Difference, right?
And then there's iron bound to heme, which is found in blood. And so that is 3 times more bioavailable than the plant iron.
No, when you said bioavailable, like that means your body
can absorb it.
Yes.
Yeah. So
you can take all the plant iron you want, but it doesn't mean your body can absorb it.
You need 3 times more than you would
of
the iron bound to heme, which is found in like red meat or to a lesser extent white meat, but red meat's the best source. And then the supplements, there's multiple problems with that. So one, I'm not saying you shouldn't supplement, but what I'm saying is that, first of all, you don't want too much iron. So supplementing with iron, like you want to make sure that you're like not just randomly taking some amount that you bought like at Whole Foods and you're just like randomly popping these pills, because too much iron can be a disaster.
Really?
Like it can age you. Yeah. Yeah, it's a very, very bad thing to have too much iron. It causes your proteins to aggregate inside your blood vessels, inside your brain.
Aggregate, what does that mean?
It means form clumps, plaques.
Oh, okay.
Form plaques in your blood vessels
like on
and
your
in
teeth,
your brain.
gingivitis.
But
right?
in your brain.
But in your brain.
Yes, in your brain and in your blood vessels.
All right.
Yeah, exactly. So it's definitely not good.
Okay.
But also it is not very...
Can that be caused from eating too much red meat too?
If you eat like red meat with like every meal, like 3 times a day, every day,
so
maybe.
a lot of red meat.
Maybe. Yeah. But so the iron supplements, you want to make sure that you're, like I said, you're not just willy-nilly like taking some random amount.
Yeah.
But also it is not very bioavailable as well. So you need things like vitamin C help increase the bioavailability, which makes spinach a little bit better because there is vitamin C in spinach.
Sure.
But so yeah, and the other thing to keep in mind with supplementing is that women that are menstruating, it is good to take an iron supplement during menstruation because they're losing a lot of iron in the blood. So for example, if you're a female
steak, like a good
if you're a female and you get your iron levels measured and you happen to be menstruating like on your period, it'll be completely different than if you get your iron levels measured like the next week. So it's always good to get your iron levels measured both times because a lot of women need to supplement. Like I actually have to supplement with iron during menstruation because I my iron levels deplete because I don't eat like a ton of red meat.
Yeah.
And also there's lots of other factors that regulate that, genetic factors as well. So that's also something to keep in mind. Like it is a huge iron deficiency is a huge problem with menstruating women. Now, when you talk about vegetarians and vegans, a lot of them are female. Couple that with that's a disaster for iron deficiency.
And girls be passing out.
And iron is really important. Like you're talking about iron. Women are procreating. They're the ones that are like, keeping these babies in
the oven.
Yeah, in the oven.
Yeah.
And iron is extremely important during pregnancy for the developing brain and red blood cells and things like that. So really important for that as well.
Yeah, I always sort of scratch my head and I'm like, you're trying to reinvent the wheel here with that pill. And I take away nothing from people who want to be vegetarians or vegans. Like that's a personal choice. It's awesome, support. But I always wonder, like scientifically, how that really affects one's body. It's
hard work. I mean, they have to make sure they're getting enough of all these micronutrients and things that they're not getting from meat. Now it's a lot easier. It is a lot easier to do now that we have the ability to supplement, like taking B12 supplements, for example, and vitamin D. Vitamin D you can make from the sun, but a lot of people are wearing sunscreen and they're indoors. And as you age, you don't make it as well from your skin.
Yeah. Things
like that regulate it. But there was some studies that were done in sub-Saharan Africa where supplementation's not that widely ubiquitous, and there was a whole slew of like clinical studies that were done in children in schools that were given the typical porridge they eat, which is like a vegetarian porridge, and they were either supplemented with meat and dairy or just the porridge. And there's multiple studies that were done. I'm just going to refer to one, but a variety of cognitive factors were looked at. So reading, writing, arithmetic scores, and then just like the way their behavior on the playground and things like that were studied. And hands down, the students that were given the red meat with the porridge scored infinitely better on reading, writing, arithmetic. Yeah.
Wow.
And this was multiple school children. So I'm not saying that like, every child needs to eat red meat for the vegan parents, but it's something to consider with, how important iron is for the brain.
Developmental kid too, right? You'd think.
Yeah. The brain is extremely, like, as the brain is developing, through the first years of life, iron is really important. It makes myelin, which it's important for making myelin, which coats axons. Myelin is like the fatty substance that coats axons in your part of your neuron. Basically, myelin's needed to transmit a electric signal from one neuron to the next, so you can like be sharp.
Oh wow. Yeah.
So iron's important for that, and if you're not getting it during development, it sets the stage for the way your brain's going to function throughout your life.
Sure.
So it's really important.
Well, what's interesting about vegetarianism, right, or being a vegan, is that it's like the idea is like really new when you think about it. Like in the history of humans, right?
Yeah.
Like the idea of like, okay, we're no longer going to do this one thing is like a really new idea. And, although like, people do whatever they want to do, it just seems like we're reinventing the wheel. Like someone's trying to, say one thing is better than the other with not a lot of time studied,
Well, I think if you think about human evolution, there's probably lots and lots and lots of long periods that humans were vegetarian because you couldn't hunt the animal. When I mean periods, I don't mean like months. Like they were vegetarian for like 3 months because they couldn't catch their game, the animal. So they were out there getting foraging, right?
Yeah.
But then
getting fish, getting whatever.
Believe me, they were waiting for that, for
that deer
that kill.
Or whatever it was.
Yeah, and so there probably were. It was probably a periodic thing. It wasn't like this lifelong lifestyle thing. It was more like I'm a vegetarian for 3 months because I can't get any meat.
Yeah. And there's also like we've gone the other way too because every kind of dish is available at any moment now. You can, if you have, if you have a job and you're employed, you can go get a steak at X restaurant at any time of the day, and you can go get a piece of fish or this or that, and so we've kind of gone the other way when it comes to like a cycle of the environment and how we're gonna,
right. Yeah, that's a good point because now it's like, it's like it used to be, you only had your meat every so often and it was a luxury. You got that bison or whatever animal it was. Yeah. And then also you were moving to get it. You were moving, you were active. That's a key. If you're going to eat a lot of meat, you actually need to be active. Yeah. Because meat, what's in meat are essential amino acids, and essential amino acids, specific ones, activate a pathway, the IGF-1 pathway, which is really important during development because it's important for growth, to make sure you're growing. But as you get older, IGF-1, what it does is it allows damaged cells to survive when they otherwise would be killed off to prevent you from getting cancer. Sure. So IGF-1 is really strongly correlated with cancer risk. But IGF-1 is also really important for things like muscle growth and growing new neurons. But that means you need the IGF-1 to go to the muscles and go to the brain. Sure. Guess what does that? Exercise. It makes IGF-1 go to the muscles and go into the brain. So again, people were more active. They were out hunting. Sure. And
the stress of a human.
Yeah.
Right?
They weren't just sitting in a cubicle. They weren't just sitting in a cubicle all day and then they went to out back and got their steak and then go back to their cubicle. God. I mean, it is a very different. I mean, you could think about what it's doing to human biology. It is definitely very different. So anyways, we're kind of getting into this.
No.
Interesting.
I know even just from when because I am so active and when I don't do anything and then I just am like, do like a whole like sitting around all day or doing nothing or, you take a lay day and it's like overeat. You just feel like shit. Yeah. And it's unreal how different you can feel if you like get out and put stress on the body and then replenish it with.
Yeah. You got to put the work in.
Yeah.
You put the work in and it's amazing how good you feel. I mean, at the time when you're working hard, it sucks. There are times when I'm working out and it's like, it's so hard. I want to stop. But then afterwards, you feel amazing and mental focus has increased. My mood's improved. And there's, of course, lots of biochemical mechanisms that explain it.
Sure.
But at the time, it's just like, you're like, oh, I don't want to do it, I want to get out. Or sitting in the sauna, you're so hot. You're like, oh, this is awful.
But you have to do it, people. You have to get out there and push yourself. Well, man, we covered a lot.
We did.
Covered a lot.
Yeah.
We could probably go for another 10, 12 hours.
Jeez. I love talking about this stuff.
That's great. I love it. Well, thank you so much for all your hard work and all your contributions to science right now because it's amazing.
Well, I appreciate it. Thanks for having me on the podcast.
Yeah, definitely.
Anything we can send people to? Instagram,
website? Yeah, Instagram, Facebook, Twitter.
Rhonda Patrick.
And foundmyfitness.com. I'm also on iTunes.
Ah, yes. She's got
and a YouTube channel.
50 different episodes, right?
Yeah,
or more.
Something like that.
Yeah, it's really good. Really great, informative stuff for anyone who wants to check it out.
Cool. All right.
Awesome.
Cool.
Thanks so much.
Yeah.